Good morning, sunshines. How are we doing today? Great. Today we're going to talk about a couple things, little different things. One is about the space itself and how you plan for a show, and then we'll end it with talking about steel. Yay! Talk about welding. Yeah, that'll be fun. To begin with, I'm going to remind you of a couple things we've already talked about in the class before, but it has been a while. One we haven't talked about since the second day of class. But again, in a proscenium theater, we're going to talk a little bit about how the stage facility itself. So in a proscenium theater, that's where the audience is on one side, the actors are on the other. You have your 9 basic stage directions: down right, down left, up right, up left, center, center. And center, center technically is where the plaster line, which is the imaginary line that connects the upstage side of the proscenium arch, and the center line, which is the imaginary line that goes down the center of the stage, cross. That's center, center. If you're ever installing a show on tour, the center, center is where you want to find the mark, and that's where you measure everything from. And that is because draftings, despite the appearance that draftings, because people put a lot of thought and energy into them, they are still created by human beings, and human beings are flawed. And draftings are often flawed. And so the only way to be sure you're centered and when you install a set is to start from center, center. If you start from one wall, the drafting may be off for a couple of inches and the whole thing's screwed. There's also several zones in the theaters. We have borders and legs that are the masking pieces. Each set of borders and legs creates what are called a zone. So you have N1 is the zone on downstage side, then zone 2, then zone 3, then zone 4, depending on how many legs and borders you have. Again, this becomes more important when you go to things like musical theater, like ballet. If you're ever N1 is a number where there's a drop after the first legs and borders, and that creates an ability to change scenery behind the drop N1, so they're N1 numbers. The electrics, again, we talked about lighting a couple weeks ago. In the audience, the electrics are called beams, and on the side of the stage they're called slots. You also have a position on the front of balconies, if you have any kind of balconies. Then on stage, the onstage electrics are called electrics. If you have any kind of onstage side lighting, they're usually called Juliets if they're downstage of the proscenium, or ladders if they're upstage of the proscenium. And again, you always number from the plaster line away. So beam number 1 is the closest house electric in the ceiling. Beam 2, beam 3 goes farther away. Electric number 1 is furthest downstage. Electric 2, electric 3, etc. as you go upstage. Yes. The wings are the areas offstage right and offstage left. A sight line is an imaginary line from the audience onto the stage, and the extreme sight line are usually the seats to the farthest right and farthest left, or the seats to the farthest up if you're using a section. Yes. Crossover is the way you get from one side of the stage to the other, and sometimes in some theaters a crossover could be a cross under or a crossover, because some theaters don't have actual room behind the cyclorama, which is the last curtain in the theater, to move behind. Again, the area below the stage is called a trap room, and then the access to that is called a trap. The area above the steel grid is what holds all the battens and all the electrics and all the flies in place. So that's the grid. Cool. Again, the second day of class, we talked about the 4 basic stage configurations, prosceniums, what we've just been discussing. You also have thrust, which moves out into the audience. You have in the round, and you have a flexible stage space. Yes? So just some reminders as we get into production, talking about different ways of doing theater that you may have skipped over the first couple of days. A production calendar is very important to the production process. There's an example of it here. You can sort of see that there are days off listed. There are things like photo calls, like rehearsals, dress rehearsals, brush up rehearsals, performances, what time those things might be from. Again, this is just for a show called Intimate Apparel from a couple years ago. But that's just an example of a production calendar, and you will discuss different aspects of that during the production meeting. Like, for instance, when first dress is, when people have to be off book. Off book means the actors have to know their lines. The tech rehearsals, in this case, the tech rehearsals are on the 11th of April and the 12th of April on Easter. These poor people had a tech rehearsal on Easter. That is sad, sad, sad. But you see there's on the 10th is a production meeting at 9:30 in the morning. So again, that would involve the technical crew. There are 3 basic production periods. There's pre-production, which is the period of time up until auditions, or up until first rehearsal, really. And then there's production, which begins at the first rehearsal and runs through opening night. And then there's the show itself and post-production, which is going up to strike and storage, yes? Now, there are going to be several things called plots that are going to be running around like chickens with their head cut off. You have a shift plot is what's here. Eventually, again, these are not necessarily full-blown the first day, but when you are shifting scenery, there are 4 ways of shifting scenery. You can have somebody carry things on. It can be a crew member or an actor, unless you're an equity house, in which case it has to be a crew member, unless you can make it part of the action. You can fly it in. You can, especially if you have a fly house. If you don't have a fly house, you may have to be able to crate something, but you can still fly it in. You can roll it in on a wagon, or you can bring it up through the floor on an elevator, or just carry it up through the floor, yes? And so as you go through the process, you will create this shift plot, which enumerates every single person, every single thing that has to move through the course of the show. Now, if you have a unit set, which adds things and pieces to describe areas, you're gonna have a lot more shifting. If you have a one set wonder that nothing changes in, if you're doing Crimes of the Heart, there may not be any shifts, right? So your crew, you need a lot less crew, but potentially the crew for a show can include fly crew, it can include elevator crew, pit crew, you can include, if you have revolves, you can have screw crews, you can have dressers, you can have sound, light, tech, all those sort of people can be running around backstage in addition to the people who are the actors on stage. Eventually you're going to have prop plots, which is a description of all the properties and where they start and where they finish and how they get there. You're going to have character flow charts, which tells characters when they're on stage and when they're not. You have costume plots, which tell everybody what clothes they're wearing when they do the thing. And you have light plots, which there's one the stage manager is going to create, which says where the cues go, and there's one that the lighting designer is going to create that shows where all the lights are on. Yes. When you are shifting a wagon, which is again anything that rolls, there are 3 basic ways of making it stop, which is very important. Anytime you have anything that rolls, having it be able to stop is very important. So in the shift, one is to use what's called a barrel bolt. Now, the thing about a barrel bolt, you can both get spring-loaded and just gravity-loaded barrel bolts, but you're going to need to have some sort of hole in the floor for that barrel bolt to go into. And usually the hole in the floor has got a little piece of glow tape on it. Depending on the theater you're at, you may not be able to drill a hole in the floor. So barrel bolts may be out of the equation. Wedges are great. The problem with wedges is they only keep you from going one direction. So if you've got a wedge on one side of the platform and not the other side, if people are walking on the platform, they may wiggle it loose from the wedge you've placed in. Usually on a wedge, you'll also have a little trick that I've found. If you staple a piece of sandpaper around it, the sandpaper will help to grip the ground as well as to grip the platform. Rubber works too. One of the great ways of stopping a platform is to use a compression lock. Again, it's just a way to, you just step on the lock and it pushes down and sort of lifts the wagon a little bit. And then when you step, it will also release. So that is a great way of stopping a wagon that you have any other way to stop it, yes. Moving flats. Again, these are mostly for Broadway flats, but also for Hollywood flats. If you are what's called flipping a flat, in other words, if you've got a flat that's this way and you want to raise it this way, you always raise it with 2 people and you have somebody foot this edge. And as you lift on this side, this person who is footing it moves back and this person who is lifting moves forward to foot it. That's called flipping a flat, yes? Then when you are walking with a flat, the person who is, if you're going this way, this person will lift and this person pushes. Yes, if you're going the other way, this person lifts and this person pushes. That's just the way it works easiest. If everybody lifts, it gets top heavy. If everybody pushes, it drags the floor. Yes. If you have to walk a flat, if you can't flip a flat, but you have to walk a flat up, again, you're going to need somebody to foot it, And you're usually gonna need 2 people on each side, one person on the right, one person on the left to lift. And so that's the way you're gonna flip that. You're gonna have to maybe foot it and then lift it up to walk it up. And then lastly is to get it down, float a flat. And this is gonna sound crazy, but it's absolutely true. When you have a flat that's up and you want it to come down, you give it a nice little push so it goes the direction you want it to, and then you let go. Because the air will catch it as it falls forward. And unless you have an enormous amount of weight on the flat, let's say you have a cornice that's huge, that can cause some weight to cause the air to be overcompensated for. But usually the air that will pick up the flat will make a nice easy landing, and it will freak you out the first time you see it. You also, whenever you float a flat, you want to yell eyes, because any kind of garbage that's on the stage is going to become a projectile and always winds up in the young people's eyes. So be wary of that. All right, let's talk about ropes and things real quick before we talk about steel at the end of the day. Usually on your fly lines, you're going to have what's called grade A manila rope. Manila rope looks like it's a little tannish in color. It has little burrs on it, so I'll be careful of those. Over time, though, those burrs get worn off, but I would still wear gloves when I'm working the rail, just because those things do get prickly. Again, 1 inch grade A manila is the standard. Some theaters have a little bit larger. I would be very wary of going smaller. Again, your braking strength, talking about your safety factor and all that sort of stuff. The 1 inch is safest. Again, usually for white tie line or cording is used to tie on flats or to tie on drops, that sort of thing. But I would not use it to secure fly lines. I would use metal for that, which again, we've got wire rope for that. You might also come across some nylon rope. The biggest caveat, nylon rope, because nylon is stretchy, it has a much higher breaking strength than cotton or manila. The problem is it's not breaking, but it's stretching. So let's say you have a piece of scenery that it's got a spike mark that comes down and keeps stretching. Well, of course, now you're starting to hit the ground because the rope is stretching. So I would literally stay clear of nylon rope if you can, if at all possible. Obviously, sometimes it's just the only thing that's available and you gotta do what you gotta do, but nylon rope is very scary to me. Wire rope is great. It is very durable. If it gets a kink in it or you have any kind of burrs that happen, throw it away. It's not that expensive. It holds tons, literally tons. You're gonna find as you work with wire rope, if you work with a steel box, there'll be color-coded lengths of wire rope. Again, you've got a thimble at the end there that is held with what's called a Nico press sleeve. The green is 2.5 feet, the red is 5 feet, the white is 10 feet, the blue is 25 feet, and the yellow is 50 feet. So if you need different sections, different lengths, that'll get you a combination of lengths. And again, those are used in rigging. We talked about the day we used when we talked about rigging. C7s are great little wire cutters. They also, if you have a bolt cutter, the internal side of a bolt cutter will be able to cut wire. But C7s are very nice and sharp and take a lot less grit and determination than wire cutters. Again, if you're using saddles and U-bolts, the saying goes, never saddle a dead horse. And what that means is that if you have a piece of wire that you're going to put a thimble in and then connect it with a U-bolt, if this line goes to hold the object, that's the live line, and this is the dead line. The saddle is the bigger part, and the U-bolt is the smaller part, and you always want the U-bolt on the dead end and the saddle on the live end, because you never want to saddle a dead horse. Yes, so that's just some information about using U-bolts. Again, the great thing about Nico press sleeves, they're very easy to put on. The problem with Nico presses is they're hard to take off, whereas U-bolts are very easy to take off if you want to save the wire rope at the end of the day. Cool. All right, a little bit about steel and we're out of here. Steel is different combinations of lead and iron. They can be flexible, it can be stronger. There's slate and other things that go into some formulas for steel. We use this thing called mild steel, which is more flexible but still pretty strong in what we do. There are other things like aluminum and galvanized steel that we use occasionally, and all of them will come in these forms that we're about to talk about. First of all, you can find steel extruded in several different shapes. So the nice thing is you can get an angle iron extrusion, you can get a channel iron, I-beams, T-bars. And again, you can, depending on how thick and how heavy you want it. For instance, a channel iron could be thick, wide enough that you could use it as a track for a wagon if you were to insert it. Now, having said that, of course, there's a height to it, but if the height is 3/4 of an inch, you put a piece of 3/4 inch plywood on both sides, you created a channel for the wheel that is an indentation as opposed to an outdentation. Angle iron also works. You could use 2 pieces of angle iron that overlap each other for tracks if you're using that, or a knife to follow the angle iron. I-beams are mostly for things like bridges and or ceilings, but T-bars are holding up these little tiles above us, am I right? So they're great for that sort of thing as well. You also have pipes, which again are fully round. Pipes, this may not make a lot of sense, but if you think about it, it does. The difference between a pipe and a rod is full through and through. A pipe has a hole in it. But because a pipe has a top surface, an interior top surface, an interior lower surface, and a lower surface, it is twice as strong as a rod. So if you just had the 1-inch rod and a 1-inch pipe, the 1-inch pipe is twice as resistant to stress as the rod is. Again, one of the things that often happens to rods, because they're not very strong with stress, is that you wrap another wire around them, and that's called a ribbed bar or rebar. Yes? Now, let's talk a second about pipe. This is also true of plastic pipes and copper pipes, not just steel pipes. But it used to be, back in the day, that a pipe was measured by its internal dimension. So for instance, a 1-inch pipe was 1 inch from the internal bottom to the internal top. That was 1 inch. But as we have gotten better at manufacturing steel and making it stronger and stronger and lighter, the wall of the steel has been able to be decreased. But because you had to still fit the pipe into the old fittings, the old flanges, elbows, that sort of thing, you couldn't decrease the outside wall, so you increase the interior wall. So the steel is thinner, so now the outside dimension is the same, so it fits the fittings, which means because the steel is thinner, that the internal dimension, even though it says it's a 1-inch pipe, the internal dimension is now more than 1 inch, and so this, just like a 2x4 is 2x4 in no dimension, a 1-inch pipe is not 1 inch unless you cut it 1 inch anywhere. So again, just some fun facts to take to the lumber store with you. There are, you can also make tubes out of it, and square steel tubes is what we tend to use in theater. 1-inch square steel tube is a standard stock for making scenery, etc. In theater. Cold joinery, in other words, where you don't have to have any kind of welding involved in order to join pipes together. Again, you have couplings, which just make it a straight line. You have elbows, which sort of bend it. You have T's, which come to an ending, etc. So there's a variety of different types of cold joints that you'll just add by glue, or sometimes they'll add a cotter pin to keep it on. If you're measuring metal, it's often nice to have a pair of vernier calipers. There's a picture of a nice vernier caliper. The nice thing is you can see that the bottom side can be used for the outside of the pipe, and the top side can be used to measure the inside of the pipe. So both of those work, yes? Anytime you're cutting or bending metal, it is helpful to have an anvil, and also to have a little heat to go along with it. If you have a torch, it helps to heat it just a little bit, and even that little bit can make it a little bit more pliable. It certainly doesn't make it, you don't want it to be so hot that it just melts. A drill press is a wonderful thing to have around to work with metal, because it holds the pieces in place. Using clamps on the table there and then that way you can drill into it using metal bits. You should never use a wood bit on a piece of metal, although you can use metal bits on wood. But again, it's not recommended that way. But you will need a pipe wrench, pipe cutters, and all that sort of stuff to deal with those sort of things. If you're adding any kind of ribs to the pipe or to the flange, you'll need what are called a tap and a die. A tap cuts an internal thread, and a die cuts the external thread of the to the piece. And again, there's a thing called the United States code that tells you how thick the ridges are, so that a pipe you buy in Seattle, Washington fits into a flange you buy in Montgomery, Alabama. It's called the American National Standards Institute. All right, last but not least, we're gonna talk about welding. Here's a little bit about an overview about how to weld.
Hi, I'm Steve Christina from Arc Academy. Arc Academy is a small beginner and entry-level welding school here in Chicago, Illinois. And what we do is we teach beginners how to weld, but everybody that comes through our door usually doesn't have any idea what welding actually is, which is the liquefaction of a base metal with heat, and then they fuse together. And there's three most common systems that do this: MIG, stick, and TIG. And what we're gonna do before we jump in is have a review of all three of these processes. Before we get started, let's talk about the common characteristics of each process, okay? So in welding, you have three basic elements. You have your heat source, your filler metal, and then your shielding gas or your flux. So let's talk about MIG welding. MIG welding, the filler metal is your electrode, and it's on a spool of wire, and it is also a shielding gas process. So the advantages to this is it's going to be much easier to learn because you preset all of your parameters. It's going to be much cleaner because you don't have any kind of slag process, and you can hit a wide variety of metal thicknesses. So if you're in a garage, in your shop, that is a great process to use. Stick welding, because it is a flux-based process, works awesome outside. Wind doesn't affect it as much, and it can also work on thicker metals really well. Another advantage of it is if your metal is dirty, if you're working on farm equipment or on a gate or even in your driveway, rust and debris don't affect it as much as the other processes. A few of the disadvantages of stick welding is you're going to have a lot of spatter, a lot of vapor, off-gassing, and fumes, so it's not something you want to do indoors too much. Another thing is if you're working on automotive frame mounts, it's not the prettiest or cleanest weld. Usually when you're working on some sort of frame, you're either going to pick MIG or TIG. So some of the advantages of TIG welding is you're going to get the highest quality weld. It's also going to be aesthetically more pleasing. It's a pretty bead. And it also works great on thinner metals. But the only problem is it's very difficult to control because you're controlling all three of your elements in process. Your leg is controlling your heat, your opposite hand is typically controlling your filler metal deposition rate, and then of course you have a non-consumable tungsten electrode that is creating your arc as you move through the bead. This is considerably slower process as well. So usually when you're working on TIG welding, you're going to be working on stuff like a frame for a motorcycle, automotive, sheet metal, something in that regard. We've highlighted the advantages of each welding process. Now we got to talk about what you're going to do. All of my students that come up to me that they're about to buy a welder, they ask me, which one should I get? Well, it really depends on what you're going to be doing most. If you are outdoors working on farm equipment, you're typically going to go with a stick welder, thick metal welding, dirtier material. If you're working on thin metals, HVAC, if you're doing frame outs, go with a TIG welding process. If you want a wider range and you're going to be working indoors, MIG welding is probably what you're going to want. Now let's get a little bit more specific about what metals you can use for each process. MIG will typically have the ability to weld steel, stainless steel, and aluminum alloys. Stick has the ability to weld on steel, stainless steel, and cast iron. Whereas TIG pretty much runs the gamut. You can weld on any metals that conduct electricity: steel, stainless steel, aluminum, copper, brass, chromoly, and exotic metals such as magnesium and titanium. We hope you...
Yay! We're all professional welders now. There are, I'm going to say, three basic types of welding. There's oxyacetylene, which is a way to combine oxygen and acetylene. Again, the torch is going to have two knobs. One increases and decreases the flow of oxygen. One increases and decreases the flow of acetylene. To strike it, you're going to have a little striker. You're going to turn on the acetylene only. You strike it. You pull the trigger. You strike it. The acetylene comes out. It's a blue flame with a lot of black smoke. And as you turn up the oxygen, the flame becomes a nice little pointed blue flame, and the smoke stops. An oxyacetylene torch can be used both to weld together and to cut apart metal. It is the only one of these that can be used to cut apart metal. So if you ever see somebody taking something apart, they're using an oxyacetylene torch. If they're putting together, they might also be using an arc welder, or what's called a stick welder oftentimes. A stick welder, you have a clamp that creates the flow of electricity to the machine, and then you have a clamp that holds a stick. And when you bring the stick into proximity of the piece, you need to be wearing eye protection because it creates an electrical arc, which is brighter than the sun. And so you need to have a piece of welding glass so that you can see the bead. I promise you, when you learn to do stick welding, you will stick the stick a dozen times or maybe 100 times before you figure out how to hold it just the right distance to create a bead that flows without sticking your stick to the weld. You can just grind the old sticks off and just keep on using them, they're just fine. However, it does take a lot of experience, and that's the one where people who have some experience as welders will make a lot more money because they are arc welders or stick welders. The other type is called MIG welding, TIG welding. It's different. There are different types of inert gas, but they're basically the same concept. It has one trigger. You pull the trigger, and it feeds through a flux, and the flux is what is melted into the weld. I can teach you to oxyacetylene weld in a day. I can teach you to arc weld in a week. I can teach you to MIG weld in an hour. It is very simple, very easy. Again, because of the arc that it is creating, you're going to need eye coverage to keep your eyes from being permanently damaged. And that is anytime you're coming across anybody who's MIG, TIG, or arc welding, you never want to look at the weld because it will burn your retina. And you will have a constant dark spot in your eye at that point. So be wary. It's just like looking at the sun, as it were. All right, 3 standard types of welds. Butt weld is when you put 2 pieces of metal side by side and weld down the middle. A corner weld is when you put 2 pieces of metal at a 9-degree angle and weld down the middle. The corner weld and a T-weld are the exact same thing, except that on a T-weld, you have it in the middle of the piece as opposed to the corner of the piece. A lap weld is that if you need to add strength to your joint, I would actually have I would do a butt weld with a lap piece, if that makes sense. If that's my problem, if the strength of the weld is my concern, I wouldn't lap welds, because you can torque them, unless there's not going to be any torque, and people can promise you that. I just don't like lap welding. But then the edge weld, where you build up and you turn the edges up, a lot of times you have to do that because you can't get inside the piece. In other words, in a butt weld, you weld the top and the bottom. In an edge weld, you can't get underneath, so that you have to weld the 2 pieces together. And so you need that additional strength of that edge in order to weld that. Yes. So again, just a quick little scenario about how to weld. Again, I'm not trying to make welders out of you, but hopefully you've got a little sense of how welders work. For next time, I need 10 sketches from you, and we'll see you then.